In the next series of videos, I'll be looking at finding the derivative of a function using specific formulas for derivatives. Let's look at a few of the basic formulas. For derivatives. First, let's note that if y is equal to f of x, then dy over dx represents the derivative of y with respect to x. Y prime represents the same thing. D sub x of f of x represents the derivative of f with respect to x. And of course, d of f of x over dx represents the same thing. And f prime of x also represents the derivative of the function with respect to x. And then we have some of the basic formulas that I pretty much assume you should know by now. The derivative of a constant is 0. The derivative of a function times a constant is the constant times the derivative of the function. And then of course you have the sum rule. The derivative of a sum or difference of functions is the sum or difference of those derivatives. We have the power rule. R is a real number here. And then number 4, we have the general power rule, which is a special case of the chain rule, which is number 7 down here. And then the main formula that I'm going to focus on today is the product rule, which states if you have the derivative of a product of two functions, say f of x and g of x, then the derivative is given by the first function, f of x times the derivative of the second, plus the second times the derivative of the first. And I guess those are some of the main ones. Let's look at the example that I have here. Find the derivative of each of the following. So the first one is y is equal to x squared times x squared plus 1 quantity squared. So if I leave it the way it's written there, I would have to use the product rule. But just to show you that there are options, I'm going to rewrite this by simplifying. So I'm going to write this as x squared, and then I'm going to square the quantity in the parentheses. So if I square that, that becomes x to the 4th plus 2 x squared plus 1. Okay, it's just squaring a binomial. And then I'm going to go through and multiply this out. So multiply through by x squared times x to the 4th is x to the 6th. I get an x to the 6th here. Then multiply the next term by x to the 2nd. I'll get 2 x to the 4th plus, and then 1 times x squared is x squared. So now I have a basic polynomial, and that's probably the simplest type of function to take the derivative of, because you just use the basic power rule. So y prime, that's the derivative of the function, so denoted by y prime, is going to equal to, let me clear this here. So this is going to equal 2, and then I just take the derivative term by term. So the derivative of x to the 6th using the general power rule would be 6 times the coefficient, which would be 6 times 1, would be 6. Then I subtract 1 from the exponent, I would get a 5. Plus, in the same way, multiply the exponent times the coefficient. That'll give me 8 x to the 3rd. Subtract 1 from the exponent. Plus 2 times 1, that's the coefficient there, is 2. Subtract 1 from the 2, I get this. Okay, so the answer comes out to 6x to the 5th, 8x to the 3rd, plus 2x. Okay, so I don't have to use the product rule here, but keep in mind, had this been, instead of x squared plus 1 to the 2nd, had that been, say, for example, x squared plus 1 to the 10th, I wouldn't want to do this because it could get messy. Okay, so in that case, I would definitely use the product rule, which I'm going to illustrate next. Okay, so I'm going to clear this, and then I'm going to say, okay, the derivative of this, y prime again, is going to equal 2, and then it's the first function, which in this case is the x squared, times the derivative of the second. The second function then is x squared plus 1 quantity squared. So let me just put this in brackets. So if I use the general power rule here, this would be 2 times the coefficient here, which is 1. So this would be 2. And then I would get, in the parentheses, saying that would still be x squared plus 1. And then I subtract 1 from the 2. This would give me a 1 here. And then I would multiply by the derivative of what's inside the parentheses, which would be the derivative of x squared would be 2x. The derivative of 1, that's a constant, so that would be 0. Okay, so that's what I would get there. Now, in the second part, then, it's the second function, so that would be x squared plus 1 quantity squared times the derivative of the first. And the derivative of the first, that's x squared, the derivative of that is 2x. Okay, so now let's go ahead and simplify. This is actually the answer. It doesn't look like the first answer, right? But if you simplify it, it'll come out to the same thing. So let's go ahead and simplify this right here. So I have a 2x here and a 2 here. Those are coefficients. That's going to be 4x. So if I multiply the x squared and the x squared here, that'll give me x to the 4th. And then I've got another factor of x. That'll give me x to the 5th. So that'll give me 4x to the 5th here. Okay, I got x squared times x squared is x to the 4th, and then times the 2x is 4. X to the 4th times the x also is x to the 5th. And then this will give me here plus. And here I would have 2x and a 4, so this would be a 4x to the 3rd. Okay, so multiplying this term here, 4x, and then the x squared, so 4x to the 3rd. Okay, that's what I get there. Okay, so remember in the first problem, the first form that I did, I went ahead and squared this out. So remember we got x to the 4th. When we squared this out, we got x to the 4th plus 2x squared plus 1. Okay, so I'm going to go ahead and multiply that quantity by 2x. Okay, so this is x to the 4th times 2x, so this will give me 2x to the 5th plus. Then the middle term is 2x squared times the 2x would give me 4x to the 3rd. Okay, 2x squared plus 2x would give me 4x to the 3rd plus, and then the 1 squared is 1, and then times the 2x is 2x. Okay, so this is then equal to, and then we just combine the like terms. So 4x to the fifth and 2x to the fifth is 6x to the fifth. 4x to the third is 8x to the third, and then plus the 2x. And that's the same answer that I got using the first method, where I went ahead and squared this out and then multiplied by x squared and then took the derivative. Okay, so you can see that if I go ahead and use the product rule and simplify, I get the same result. Again, I want to point out that had this exponent been larger, then I wouldn't go and simplify it. I would just go strictly to the product rule and then simplify. Okay, let's go to the next one. Okay, so I have y equal e to the 2x, x to the 10th. So I have a product of two functions. Now if this right here had been just a plain old 2, then I would just say it was 10 times 2 is 20. Subtract 1 from the 10, I get 9, using the basic power rule. But because it's a function of x and a function of x, then I have to use the product rule. So here's the way it works, and I'm just going to say y prime, that's the derivative of the function, then is equal to, so it's the first function, that's e to the 2x times the derivative of the second. Now the second is just plain x to the 10th, so just using the basic power rule, that would be 10x, subtract 1 from the 10, this would be 9. So I get 10, or e to the 2x, 10x to the 9, plus, then it's the second function, which is x to the 10th, times the derivative of the first. Okay, the derivative of the exponential e to the 2x is the exponential, and this comes from the list of formulas that I went over a while ago, and this is going to be times the derivative of the exponent, which should be 2. That's basically the answer. You could rewrite this, or reorder the terms if you wanted to, depending on how the answer is wanted by your instructor, but this would be, say, 10x to the 9th plus 2x to the 10th e to the 2x. Okay, so that's two examples using the product rule. I'll have some other videos on computing the derivative of functions using a variety of formulas. And again, as always, if you have any suggestions on topics or types of problems you want to see, please subscribe, and I will consider your suggestions. In the meantime, I'll see you in the next video. Thanks for watching.